Well, good morning, everybody. Here we are on Friday morning, just on the very beginning of what is going to be a highly impactful weekend across so many states, stretching from the southwest all the way to the northeast. But I always find it amazing as you look at this, just to see how unassuming the main culprit for this massive winter storm is. It's just this area of high pressure. That's it. That has been forming for about 10 days. It started over the Arctic, and now it's pushing its way down into the south central United States. In the upper levels of the atmosphere, there is a little shortwave right here, another one that coming off of California, which we've been trying to understand all week, the phasing, which we'll talk more about in a few moments. But the reality is what is making this storm system the way it is not some intense, deep area of low pressure. And that's why it's going to last multiple days. It's instead just this. It's kind of neat. Let's go from the surface up to 850 millibars. That's roughly 1 mile above our heads. And what we're getting, we often, when we teach new students how this works, is we're getting something called the deformation zone. So if you look at the flow coming out of the north, it makes a turn. Why it makes a turn is because flow coming out of the Bay of Campeche and then the Gulf is also doing that. And right in the middle here, we have what's called a deformation zone. We have these axes by which we deform and dilate the atmosphere. And it's this one right in through here on which we expect our front to build. It's a process called frontogenesis. So you have warm air pushing toward cold air, and the two of them squeeze the temperature gradient, and that is how you make a front. You have to increase the temperature gradient. So frontolysis is when you weaken the temperature gradient, all right? Now, that temperature gradient that happens right along here that's getting squeezed is going to have a lot of warm air. It's going to go over the top of the cold air, and we've been detailing all week long about how that's going to give us the spread in precipitation type, which we're going to take a close look at in a few moments here. But this is going to be aided in the upper atmosphere by a short wave that's moving through Canada now and a cutoff low that's been over the southwest, just off the coast of California. So it's going to come in two waves. You're going to have a lead wave that moves out and a secondary wave on the backside that comes in. So watch the precipitation as I walk through this, coming in two distinct time periods for this whole section of the United States. All right, I told you that cold air came from somewhere. And remember, we started talking last week about big ridge building into Alaska, one coming through Scandinavia, pinching the cold air that typically sits over the Arctic. And now you can see with all these black lines, I just went to Jonesboro, just as an example, to trace back where the cold air is going to be by the time we get into tomorrow on Saturday. And it's cross-polar. I mean, it started in the Arctic, almost over Siberia, and here it is. And so the net effect of all of this is to give us one of the most colorful all hazards maps that we've seen. Winter storm issues extend from parts of New Mexico all the way through into pockets of the Northeast. There are extreme cold warnings and watches that go north to south through the middle part of the country. And we have ice storm warnings that are out and a much broader area of winter storm watches. Now out west, we have gone over very stagnant, and you can continue to see the air stagnation issues, the valley fogs in California, and the presence of the large ridge that basically displaced all this colder air has put them into a pretty interesting situation out west, which we do need to talk about as we go forward here. But just looking at how much the temperatures have already changed. Now remember, this is just compared to yesterday. And yesterday, these temperatures were already off by this much. So over the last couple of days, huge drops in temperature, 30, 40, 50 degrees in places. And early this morning, this is what our temperatures look like. So just a shade before 6 a.m. Central Time. My kids don't have school today. It's an e-learning day because it is too cold for them. They have a threshold that they use with wind chill, so they won't let the kids stand outside. I believe a lot of Chicago schools are closed as well. But the farther you go toward the north and west of Illinois, these temperatures, Grand Forks is minus 20 this morning. And that's it. That is your action right there. And that is going to be the front that gets squeezed. And so this is just going to be a system that moves its way all along that area of frontogenesis. Now, I mentioned the West. I want to point something out. When you look at the statistics since the beginning of winter, December 1st, we're like, what are you talking about? It looks pretty good. But you have to understand, this came all in early December when we saw a massive ridge sitting off of California. The flow went over the top of it and just kept giving us clippers. Remember all the clippers we talked about? And then at December 21st, that ridge broke down, a trough went in here, and then California became drought-free. Do you understand, though, that each of these, whether there was high or low pressure here, we never saw the jet stream extend across the country, and this area went into exceptional drought. I should have continued drawing that all the way to the mid-Atlantic. And we've got several climate reporting districts that start in Texas and go through Oklahoma and into Arkansas that have 134s in it, and also some in Nebraska, which we need to talk more about in a few moments. I was having a conversation last night with my friend and colleague Eric Hunt, who works at the University of Nebraska-Lincoln, about the lack of snow in this area and what it's going to mean for the major river systems in this part of the plains and western Corn Belt. But these 134s, it's the driest start to any winter on record. And the reason why I say that, and our records again go back to 1893, is this storm system coming through here has the potential for putting down 3 inches of liquid equivalent. Now, some of it's going to be snow, some of it's going to be ice, some of it's going to be rain, but there's moisture in this. So hydrologically, this massive storm system that honestly has put a lot of fear in many folks over what to do as we concern ourselves with the impacts of it. Hydrologically, this is a very, very important system that comes through. Now, real quick on the west, since the start of the new year, look how dry we've been in Washington, Oregon, and Montana. And that dryness is a important signal that we have to watch to see if it changes, because while snow, we talk a lot about California, it's drought-free. There's snow in the Sierra. The reservoirs have, 28 million acre-feet of water in them already. This is a very concerning signal going forward. And it's also concerning because what were the preseason indicators? That this area was going to see plenty of moisture because it's a La Nina. We typically hit here and here with La Nina moisture. And so far this winter, we've not had it. So let's think through this pattern, understand the risks for the main winter storm system, but take a broader look at the rest of this now that we're, getting up to the day the winter storm starts. All right. Did want to show you this last 30 days, again, just to stress the importance of the moisture coming through these areas. We need it, but take a look at the Intermountain West. Look at the Four Corner states, look at the Northwest, parts of Montana, very, very dry too. Over the last 60 days, we can really begin to hone in on just how dry the Four Corners through the southern plains over toward the Delta and Mid-South have been, and how much the southeast up to the Mid-Atlantic has been dry as well. So I just say all that to stress the importance of this map. This is the WPC forecast of total precipitation. So if it's snow, it doesn't matter. We're giving you the liquid equivalent on this map. And so to see 1 to 3 to 4 inches of total liquid coming out of this in these driest areas is going to be critical. Now, as I said, it's not all going to come down in the form of rain. And a resource I want to make sure that you're kind of playing around with this week and are looking at, just go to poweroutage.us. I'll be watching it all weekend long. As the storm system goes through, you're able to hover over each state. You can even drill into each state if you want, and you'll be able to see how many customers are without power. I think it's important for us to monitor this. If you are one without power, you're not going to be able to monitor this. But if you just want to see how impactful of a storm system this is going to be, this is a very, very valuable resource, poweroutage.us. Okay. All right. This is where we're going to start. We do have some of our new high-resolution models up and available. They just don't run out long enough to show you them for the early part of this week, but here's the new NAM forecast. So we're going to compare several models today. This is by 1 o'clock this afternoon, Central Time, getting into this evening. And already at that moment, in the models, we're watching for ice here and snow kind of building down the high plains. Now remember, you've got 2 events. There's still another wave sitting on the back side of this. So as I play through tonight, this is tonight, 7 o'clock tonight Central Time, into around midnight. You can see the ice already spreading through the Red River toward the Arkansas River and eventually toward the Mississippi. And then we've got into early tomorrow morning, getting toward midday tomorrow. And then as we play this through tomorrow afternoon and evening, that first wave spreads its snow through northern parts of Arkansas, Missouri, Illinois, Kentucky, Tennessee, and eventually gets over into parts of southern Indiana and Ohio. Now, if by tomorrow night you're going, where is this thing? Round 2 is here. And you can already see the ice continuing to spread in this area. And as round 2 emerges on Saturday night, it then comes out of Texas. And this rain snow line is going to be very difficult to predict. We're just going to have to watch it in real time. But very heavy freezing rain. That's why the freezing warnings are out. And then we get into Saturday evening, playing through Sunday morning. And that is when the second wave, by Sunday morning, moves out of Texas over the Delta and moves its way into the Mid-South. So do you see how there's 2 separate pieces to this? Okay, let's go and have a look at what the model's suggesting. Let's start with ice. If we just play out the total accumulated ice, again, this is through tonight, getting into tomorrow morning. Remembering we're adding to this on Saturday and Saturday night. See this? We're actually going off the color bar. And this goes all the way toward Sunday at noon, which will still be a storm system in the Northeast by then. We're going to have to talk about the Northeast with another model. So we're focusing here. Now, my calculations, when I say ice, I'm also incorporating the precipitation flag for sleet. So when you see these numbers going way up over this, we have the potential for quite a bit of freezing rain, well over 1/4 of an inch, but there's also sleet mixed into the calculation. But this is your mixed precipitation area. That's the way to look at it. I then want to show you total snow from the NAM. And as we just play for it, I'll play it relatively quickly so you can see it all here. It's got the heaviest snow bands sneaking right in through parts of central Oklahoma, northern Arkansas, southern Missouri, and then it follows the Ohio River. So right in through there, according to the NAM, is where we're expecting the heavy snow. But understand, we're not getting the second piece of this just yet, right? We're going to watch more of this accumulate in some of the other models. I also want to show you winds, just to be aware that we could get some stronger winds out of this all the way through Sunday. We will be watching for wind speeds up here 30 plus miles an hour, maybe cracking 40, and then some stronger winds here as you get on this side of the Appalachian Mountains. So that's just one model. I have found it quite entertaining to watch actually non-meteorological people laugh at us meteorological people as we go back and forth on which model we like. Now, you got to understand, on Facebook and Twitter, where everybody's a hero and can hide behind their screen, everyone's like, oh, ECMWF versus the GFS versus the AI versus the MB, and then we just love to bicker back and forth. Well, some of us do. I don't play that game. I don't have time to play that game. What I can do is simply just show them all to you. That's why I build AgWeather, so you could see the models and compare them. And what I hope over time is that you start to build confidence in one model or another. You don't build confidence so you can be an armchair quarterback and go out there and rip everybody's head off on why you love your model, but you can at least just go, hey, look, I do notice that. I mean, the kids asked him, like, all right, you want to know something? My son's name is Graham. I'm like, Graham, look, Champaign, European model's given us almost 6 inches of snow. The GFS, though, keeps the system farther to the south. We're looking at 2. And you know what his question back to me was? Am I going to be able to pack this up and make a snow fort and snowman? He's 13. This is still fun for him. I said, no, that's going to be the ultimate problem. So just so you know, we argue all the time about it, but there are differences, and we cannot ignore them. Again, that's the Euro and that's the GFS. And if I'm in Kentucky or this part of Tennessee or in Arkansas, this is huge. And whatever app you use may give you one model versus the other. My app gives you all of them. The weather app that I built, the agweather.com, the web application, it's got all of them. Interestingly enough, the AI model is an interesting blend between them. And I haven't even spoken at all about the snowfall totals that are expected in the Northeast, which again, Matt had an interesting perspective on. Maybe these are being over forecast a little, but I don't know. Let's just keep looking at it and watch the evolution. Now, earlier this week, we did model comparisons over time. We looked at trends. There's been a very distinct northward trend in this. I'm just going to tell you why that is very quickly. The first thing is the extent in the early model runs of how far to the south the cold air was going to make it was overdone a little bit. Now, it's still cold, do not get me wrong, but some of the model runs early were driving that, especially in the lower levels of the atmosphere, much farther down. Not the surface, but the first mile. And then what often happens is that as the storm system is better resolved by the models, you get in the production of clouds and precipitation, there is latent heat that is released. So the vapor converted over to the precipitation, the liquid or the solid, releases latent heat, and it changes the temperature profile. And so it's quite common to get a northward trend in the heavy snow track. We watch for it and we talk about it. But I do want to point out that the model that tries to blend all this together and assess what all the models are saying is the blended NBM, and it is extremely aggressive on a massive snowstorm in the Northeast. And you're going to just have to understand we need to put some big question marks on this. Now, I'm building you all a new system. It just takes a long time to get this code work done, and I travel extensively for work this time of year, so it's hard for me to get fingers on keyboards when I'm behind the wheel of a car or on an airplane. But I'm working on this new system that's going to be able to show you all of these models. You can click back and forth between them and zoom in and out. But here we go. This is the new European forecast. There's our 2 waves. And I just wanted you to see why the models are showing you something different. Now, as these waves kind of try to phase and kick through, what will be most critical is this wave that comes out of California and how far to the north it goes. That is one of the reasons why when you look at, let's just go look at precipitation type and intensity. That's one of the big reasons why the European model does this with the precipitation. So there's the high pressure. Now we're getting here into Saturday morning. And if you just play this forward, you can see there's the pinks representing the ice, the greens rain and storms, and the blues are snow. Now, when you see the European model, because of how far into Illinois it takes that wave, there's much more of a northward extent in the snowfall. And as we just keep going, it also brings much greater snowfall into the northeast. It's all about the wave position. And that's the system getting out. Now I'm going to keep playing this because we were talking about another clipper coming over the top of the Great Lakes, possibly winding itself up next week, next Thursday into Friday in the northeast. And the newest progression is this high pressure is building in fast. The wave goes through the Great Lakes and ends up offshore. And so this had previously been forecast to go through Boston, just walloping the northeastern United States, and it's now off a bit. So just staying in tune with this next week, let's go out there and just have a look now at what the European model is suggesting for snowfall. And as we have a look at these data, I'll tell you what, let's zoom in just a hair, because this is going to be the main corridor that we're going to watch. If we look at this, here we go. So this, where are we? This is Sunday morning. And if I'm in Indiana, which by the way, the most texts and tweets and everything I got about the model comparison battle was from Indianapolis. Something's going on here. You guys are going at it. Anyway, I can understand why. Because the European, look at that, it's bringing 5.5 inches, 6 inches to snow there. My little sister lives just outside of Indy. She's a principal at high school there. And she's like, hey, what am I expecting this weekend? And I told her, because she's been watching your little model battle go back and forth. Well, anyways, this is what the European has, getting us all the way out there to Monday into Tuesday. And we've watched the models waffle a lot on this. They've now come back over to very aggressive snowfall totals in Oklahoma. And we see this swath now spreading much larger than it is in the GFS. Now, the European model, as you get over here toward the northeast, this is pretty widespread, 6 to 10 inches of snow. But there will be locally, because of topographic effects, some places with quite a bit more. Next, if we have a look at the icing effect out of this, let's flip this over to ice. There we are. And let's start playing this one. This is Saturday getting into Sunday. Now, Atlanta, you've been the biggest wild card. We have watched repeatedly the risk go back and forth over Atlanta. European model still has you getting ice. This is an elevation issue here. If you've never been to this part of Georgia, they're a little higher. I don't know what they are, maybe 1,000 feet above sea level, and that has an impact. But if you come through parts of North Carolina, in fact, after this recording, I'm going to go jump on a meeting with my colleagues out in North Carolina just to discuss this threat. But they're looking at significant icing here because of cold air damming that happens up against the Appalachian Mountains. But right in through here, this area, it's been pretty well highlighted all week long as to how and why we were going to have the undercutting cold with the much, much more mild air aloft, setting up an icing event here. So, folks, that's what the European model solution is on this. We've got a closer look and, the tools to watch as we go forward. I'm going to tell you what I want you to do. All these models are great. You can look at them all day long, but you need to just go here, weather.gov. Whoops, I can't even spell weather.gov. Weather.gov. And when you go to weather.gov, you can drill into your location. I picked on Jonesboro earlier, and you can see all of the risks. They even put together these great graphics on what they expect. They are the authority, okay? Please take advantage of this. Oh, my goodness. Look at their event total ice accumulation map. Well over an inch through here. That's just south of Memphis. Man, this is a tough system. Okay, I wanted to show you why the models are different still. If we play this forward, remember I said you got to watch that wave coming out of California, Baja California, Mexico. Take a look at this. Where does the wave show up by Sunday? See where this is early morning Sunday. See how the European is here and the GFS is there? Watch the difference this makes. So let's just pick it up here, playing this forward through Saturday. The difference in the wave and how far it makes it is the difference in total QPF, or quantitative precipitation forecast, north. It's also changing where the ice is going to be. Changes how far you can bring the mild air. Look at this. If I'm in Tennessee, I look at the GFS, it's like all ice. European brings in the rain in eastern Tennessee. And that is the model difference right there. It's the position of that shortwave trough. And it's also what accelerates the European model to take the system through the northeast quicker, dumping more snow. GFS is just a hair slower. What we often do just to understand it is just say, let's just go look at the ensembles. And if we look at the European ensemble, the deepest shade of red you see here is the probability. It's over 90% of getting at least 3 inches of snow. We can keep stepping this up. There's your 6-inch swath, very well defined in the ensembles. And over a foot, we're looking at parts of Oklahoma. Right here along the Ohio River's got the risk. And then this is mostly enhanced by elevation, but here enhanced by lake effect there. But coming right over into this part of the Northeast, we have this risk of a foot or more of snow. And this is impressive. All right, so again, if I just take it back to 3 inches, there you go. That's your snow swath out of this. Next, I do want to make a point of how wet this system is. This is the probability of over 1 inch of liquid equivalent, and here's 2 inches of liquid equivalent. And this is hitting very close to where some of our driest areas are. If we could get this to back itself up, 400, 500 miles, then it would hit the driest areas. But speaking of dry areas, here's who's the driest in this next 10 days. It's almost all of Canada. It's most of the northern half of the United States, except for the Northeast, and much of the West. This is the probability of staying under 1/2 inch of total liquid equivalent. If you want to go down even farther to who's staying under 1/10 of an inch, with all this Arctic air that's so very dry, with incredibly low dew point, we've got very high probabilities of staying under 1/10 here, and then throughout the West. Okay, what needs to happen in the West is that we have got to break down this ridging that keeps deflecting lows here to keep finding their way up toward Alaska in this case. Go all the way out next week and beyond. We keep seeing the models attempt to toss low pressure and fronts right along the coast, but they just don't seem to have what it takes. And even out there to the 4th of February, it's a whole lot of this still, which we've seen repeatedly this winter. I mean, honestly, the only time period where I didn't see this was like December 21st through January 4th or 5th. That was probably it. So the net effect is to give you a week 2 precipitation pattern that when you look at all the models, I can just zoom in on one, looks something like this. We go over drier, we maintain the cold, and the West does not get in this action. Now, let's talk about that cold, because right now developing over the Hudson Bay, coming out of the Canadian archipelago, is the polar vortex lobe. This is deep in the stratosphere. It is co-located with the coldest air at the surface, meaning it's reinforced and has some staying power. Here's today's high temperatures on Friday. That's Saturday, high temperatures in Amarillo, 9. We're going to dip this cold air far south, getting all the way south of, eventually all the way south of like San Antonio. Again, these are highs. We get into Monday, Tuesday, and Wednesday. We just keep the much colder than average conditions around. This is Thursday. If I show you the minimum temperatures, all right, this is today's minimum temperatures. I really want to specifically hone in on Texas on this. 4 in Amarillo, 27, so below freezing down here in San Antonio. We should get Houston down to freezing. And my goodness, Dallas 14, and the next morning 6. This is Monday morning. This is a significant Arctic outbreak. Monday seems to be the coldest of the days. This is going to be very problematic for Texas, and we need to get prepared now, because if there are power outages, we may go through the weekend without those being repaired with having such cold temperatures. And I'm worried about burst pipes and things of that nature. So this is Monday morning, Tuesday morning, and Wednesday morning, and all the way up to Thursday. We just maintain this cold air. To show it to you in terms of anomalies, this is just, again, a difference from normal every 6 hours. The surge of Arctic air through Saturday into Sunday, and now Monday. We're still looking at Monday. Behind this, temperatures 30 to 35 degrees colder than average. And then there's another shot of it that comes as we get out there into mid to late week. It just reinforces it. Here it is across this whole corridor. When does it start to warm up? Well, we're now into the month of February right here. And you start to see warmer air coming back to Canada compared to average, and the colder air is trying to exit the southeast. We do expect it to flip over. It'll flip-flop itself around. But I want to point out that the newest CPC update for January 30th through February 5th is the high risk of hazardously cold temperatures across a broad area of the eastern half of the United States. So this has got some long duration to it. I do think it's going to have the ability to come back as well. Because if you look at the zonal mean flow in the stratosphere, we have the weakening of the polar vortex happening now, and then the model ensemble average is to keep a weaker polar vortex through the month of February. And I think that's going to inform some of our longer range forecasts like this one, which is the analogs I've been using, 18, 14, and 09 for February. I'm going to come back to this in a few moments, but what I'm trying to reinforce is this. What is going to be top of mind for me going forward is just to continue to observe what's happening in our western states with respect to our snowpack. And what I forgot about this, and this is what my friend and colleague Eric Hunt, who's based here out of Lincoln, told me. He's like, don't forget, you can click on these and see the graphs. So what it shows you is the historical averages, the ranges, and the river system you're on, or the mountain system too, and you can see the black line tells you where you are currently set up. And what Eric and I were talking about yesterday is the North Platte and the South Platte, because right now the North Platte is at 70% of its median. It's near the bottom of the distribution. The South Platte, 58%. And what I'm concerned about here is that this is setting up this whole section of the United States to start to have increased risk of spring and summer drought conditions if the summer thunderstorms and spring thunderstorms don't return. Go to this site and do this. In fact, I'll link it in the show notes below so you have it, or the comment section. And you can just click on these areas and see how things stack up compared to normal. And since we were talking about it, I just want to show you, like, if you go up here to the Upper Columbia, we're closer to average here at 79%. But if you come over to like the Olympic, the Washington coastal ranges, boy, we've got a lot of room to make up in these areas. So just a great resource. Please take advantage of it. All right, I've been hopeful that we were going to knock this out and start to bring better moisture into the West as we progressed out of Phase 6 into Phase 7 through Phase 8 and then back here. If you want to bring storm systems back to the West, boy, a Phase 1, 2, 3 transition, I'm talking this area, would be critical. And the models are still hinting at it, yet they're not showing it. See, this is a 1-week sliding window of precipitation. So this is the next week. There you go. That's your anomalies. I get out there and, okay, maybe out there into week 2 we bring a couple of fronts into the West. But, this area goes over dry. But it's not sustained. In fact, by the week that ends mid-February, we're back over drier here. And by the way, we need to condition ourselves to not bank on this coming through. Going further into February, I see these waves attempting to come back. Maybe this is when the MJO gets over into Phase 3, but I see this as a problem. Over the next 30 days, we see too much dryness in the West, despite the fact that the models are attempting to revive that. If I show you all of February, I want you to be cautious with this, but it does appear that we're going to go drier here, although that does not jive well with the historical analogs. The years I'm most closely using tended to be wetter in this area, snowier in this area, access to plenty of cold air in the month of February. We tended to run the risk of being drier in the plains, drier in the southeast. Again, these are just my analogs to kind of give you a hint. We haven't talked much about long-range weather all week because of the focus on the storm system. So let's go ahead and wrap this up by looking at South America. These models are still pretty conclusive on wetter than average conditions sneaking through here. Last week, Mato Grosso was 7% harvested. We'll get a new update on that this afternoon. But the models are quite keen on going over very dry in southern Brazil and Argentina, including Paraguay and Uruguay, and so is the GFS. Now, if this rain does come through and it is much wetter than average, we could slow the harvest progress. I don't know that it's going to be newsworthy, but it's something to be on the lookout for. The reason why I don't think it's going to be newsworthy is if you look at Brazil, we're now entering week number 5 of new record high NDVI values. So this crop looks pretty amazing from space. And again, this is masked for cropping areas, not the whole country. I do want to note that from Jan 21 to February 21, that the European model could, if correct, work against harvest pace in this area, while running the risk of Argentinian and southern Brazilian drought. There's something to it. And I think we're going to have to spend the weekend thinking about it once we get this winter storm through, so we can kind of devote some time and resources to other areas around the world. But I want to watch that carefully. Okay, that's it. You all have a good weekend. Be safe. Please make sure you're taking the right precautions to get yourself prepared. I was a Boy Scout, and we drilled into our heads, be prepared. And this is one of those times we're just thinking clearly about what to do and trying to act as rational as possible is what's going to be your best bet if you're across the South dealing with this storm system. So please take care. I'll talk to you on Monday. Thanks.